Current reality capture devices have sensors that are able to take a lot of different types of data, and we need to have tools for automatic segmentation, detection and classification of this data. Point cloud classification automates this process by leveraging machine learning algorithms to assign class labels to points. This significantly reduces the manual effort required for data interpretation and allows for a faster and more efficient way of analysis, object recognition, decision making and planning. At the moment, we have already available tools for automatic point cloud classification in the below software. Leica Cyclone Register 360 Plus, it has predefined models for indoor and outdoor environments. To run this tool, you should download and install the pre-classification package for the software. You can download it from the online help site. Click the Classification Manager button, select the desired model and run this tool. Keep in mind that only visible points will be classified, even if they are in another sitemap. If you want to classify a mix of indoor and outdoor points, then place these setups into separate bundles. When classifying the indoor setups, select all outdoor setups and use Show Hide Point Clouds to hide the outdoor setups before selecting Classify Visible Points. Then repeat this exercise for the outdoor setups. After the processing will be finished, you could manually move the points to the desired class. Also, it's possible to apply different settings for classification to different bundles on the import stage. Leica Cyclone Pegasus Office. Here's the classification package available from default. Just check the point cloud classification option to identify and classify features in the high-resolution point cloud. After the classification has been performed, use the rendering style tool and select classes to visualize the classified point cloud. Open the asset panel to hide or show specific classes or to manually reclassify portion of the point cloud. If you hide some classes and then export, these points will be excluded from the publishing result. You can use this option if you want to export data without noise, pedestrians and cars. Leica Cyclone 3DI. It has 4 different predefined models for classification. The training of classification models is an ongoing process, therefore model updates regularly released, as well as the new classification models. To download and install the classification package, just click the Auto Classification tool. It will install everything, and after that you'll be able to use it. Select Point Cloud, run this tool and choose any of the available models for classification in the list. If necessary, use the manual classification to improve the result. At the end, you can split the point cloud by class layer. Click for the Explode by Class button. Additionally, you can apply standard filters for the classified point clouds like distance, walls and floors, real color, inspection value and others. From all of this software, you can export the classified point cloud to LGS format, which can be opened in the free viewer Leica TruVIew, published on your own server via Leica Cyclone device, or open via CloudWorx plugin. This plugin is available for all popular CAD software. It has embedded tools for automatic feature extraction, with it becoming possible to automatically feed different objects to point clouds like walls, columns, doors, windows, pipes, steels and others, much more easily if your point cloud has been split by classes. An additional very useful type of data that we are collecting while reality capturing is panoramic and highly detailed images. From them we can understand the type of element and material, clearly see small details, identify text and do much more. Register 360 and Pegasus Office have already artificial intelligence tools to work with images, like blur people and vehicles in the imagery. Blurring in Leica Cyclone Register 360 Plus. Select Setup and click on it with the right mouse button. In the pop-up window, select Edit Image Blur. In the appeared window, you will see the panoramic image where you could click Auto Blur, and then software with artificial intelligence will detect all people and car plates on the image and will add blur to them. For the mobile data from autonomous devices, select the waypoint in the right bottom corner and click the Edit Blur button. Blurring in Leica Cyclone Pegasus Office. For the Leica TRK mobile scanners, we can apply the image anonymization function directly in the field while capturing the data. In that case, all people in car will be blurred right after capturing. Or we can do it later in the office via desktop software. For that, at the finalize stage, you just need to check the relevant option and click Finalize button. additional artificial intelligence tools for images available in MMS Deliver software for road sign recognition and crack index processes. You can find them in the road assessment tools. For the road sign, before starting with automatic traffic sign recognition, you need to follow the requirements for database preparation. For road sign recognition, it's needed a library of traffic sign of the corresponding country in JPG format. In the same folder must be present these 3 files as shown beside. For each sign, you need to describe the properties that will be automatically implemented in the shapefile attribute table. As a result, you will get points located in the right position with predefined attributes and represented as a shapefiles. Also, it's possible manually add other signs using the normal traffic sign recognition or to modify wrong identification. The crack index process works with the data from pavement cameras. It's listed in order the cracks surveyed in one designated region of interest, ROI. This ROI is analyzed along the trajectory using the images to evaluate the condition of the road. The crack index process works only on RGB images, not on the point cloud. At the end, the tool generates inside a field of features selected the number of tiles affected by issues found in the imagery. To find the cracks index, the software divides the imagery internal of the ROI into many parts per side, and it calculates an index related to the total number of cells analyzed. The output of this tool is a shapefile of points with an attribute of the crack index. All the above tools highly speed up processing time and make it autonomous, but what if we need to detect some specific elements in our scene? For that purpose, let's see how we can use imagery data for custom object detection. First of all, we need to get dataset for artificial intelligence model training. So use the below tools for image extraction from the software. For Register 360+, on the report stage, select the PANA images option for the export and click Publish. For Cyclone Pegasus Office, on the Finalize and Export stage, select the Export JPEG option and click Finalize. The software will generate for us separated panoramic images with a TXT file which contain information about position of each image and orientation. Next, we need to decide which objects we want to detect. Let's try to find fire hydrants and manholes for the TIR-Key mobile dataset, and for the BLK arc dataset, exit signs and fan coils. Now we need to label our images, and for that purpose you can find a lot of tools on internet. I'll be using Roboflow for that. If you want to repeat, go to the site, create an account, create a new project and add your dataset there. Then start to annotate your images. You can add more layers if you want. For example, let's add grain grade layer. Use a simple fence for annotation. When it will be done, you need to submit your images and add them to the dataset for training. After that, you need to go to the Generate tab and apply some transformation and augmentation to your images. This tool will create copies of your images with selected options like a mirror, color change, orientation change, etc. With these changes, your dataset will be much bigger and the training process for the artificial intelligence model will be more accurate. When the dataset will be ready, we can generate a snippet. It's a code that we need to insert into our training engine. For the training and deploying code, I'll be using the Goggle Collab platform. It's a product from Google Research. Collab allows anybody to write and execute arbitrary Python code through the browser, and it's especially well suited to machine learning, data analysis and education. In the description you can find a link to the page with the predefined scripts. Just follow instructions and run processes one by one. To import your own dataset, go to the section Preparing Custom Dataset to step 5 Exporting Dataset and insert your code there. Run this process to start importing your labeled data from Roboflow. The next step will run the training. The more epochs you will set, the more time you need for the training, and the more accurate model you will get. After the training will be finished, you can see some statistics about the result and add your own file to check how it works. I will add some video from the same area but with a mirrored effect. All results are automatically saved to the Runs Detect Predict folder. Let's download it and see what we get. As you can see, in the place where the object was detected, rectangular fence appears with confidence level information. If you will get too many redundant elements, you can increase the minimum level of confidence, or opposite way. If you get too poor results, try to reduce the level of confidence. To more accurate behavior for the model, we need to have more data for training. but I'm thinking it's very nice result for such a small test. When we apply this tool to images, each image gets an attribute with information about which object was detected on it, so we can combine this information with coordinate and orientation parameters that we exported before. For the BLK-ARC small dataset, I will use simple Excel to visualize and highlight areas with a bigger number of detected elements. I'll use a bubble chart for that. Later generated image can be imported into Leica's Register 360 Plus and used as a background for LGS files. With the TRK dataset, we can put everything into GIS software to visualize these areas with detected objects. For example, it could be Hexagon Map Enterprise software. It allows you to store your geospatial data and provides a dynamic delivery of geospatial analytics and workflow to enhance business intelligence. You can create web or mobile applications with this platform, use previously collected data or get it in real time from IoT sensors, and you can use a wide range of tools for the visualization purposes.
Thanks for watching this video. I hope you found it interesting and you gained some valuable tips and tricks from it. Today I aim to show you how artificial intelligence tools can be used in our daily works effectively. However, it's important to know that there are numerous other tools available for us to explore. For instance, there are software applications specifically designed for working with airborne point clouds, enabling classification and analysis. Additionally, devices like BLK 24/7 can detect objects in real time within point cloud data. When it comes to images, there is a software that allows the creations of custom object detection and classification algorithms for airborne ortho images. Moreover, with the advancements in artificial intelligence, we can perform object segmentation on images and apply this result to point cloud data. It was indeed a challenge to cover everything comprehensively in just one single video. However, I am genuinely interested in your feedback, so please let me know what you think about it, and if you would like to see more videos with the same topic in the future. Your feedback is really valuable for me, so thanks again for watching and see you next time.